the xy dx is equal to negative 2y squared minus x squared dy, or just you can distribute the negative there, so it will become 3xy dx is equal to x squared minus 2y squared dy. Now we'll put dy over here, so dy over dx is equal to x squared minus 2y squared all over 3xy. So as you can see, we can separate this kind of fraction to make it simpler. So we'll have dy dx. Oh, this should be dx over dy. So dx over dy is equal to x over 3 minus 3xy, that's 3xy, 3y minus 2y over 3x. So this is our equation, and with this we can see that this could be arranged in a linear form, and we will do it this way: dy over dx over dy is equal minus 1 over 3y times x is equal to negative 2/3 y times x to the negative 1. So here we can see that x to the negative 1 is not an ordinary linear equation, so we will use here we can use the Bernoulli equation. So to proceed, we let u is equal to x 1 minus n, wherein our n is negative 1, so this will become x squared, and du will become 2x dx, and with respect to y we have du over dy, 2x dx over dy, and therefore we will get 1 over 2x du over dx equals to dx over dy, wherein we can substitute this equation to the original one, or dx over dy minus 1 over 3y times x, negative 2/3 y x to the negative 1. So this will become wait, sorry 1 over 2x du over dx minus 1 over 3y x equal to negative 2y over... Okay, I guess I made some mistake. This one must be du over dy, so kindly correct it. Thank you. 3x. Sorry for the noise outside. And with this, to remove 1 over 2x here, we must multiply it by 2x. And we have du over dx minus, will become 2x squared over 3y equals negative 4/3 y. So this is now a simplified form, and we can solve it using linear equation. But first we must remove all variable x and make it u. So here our x squared now will become u. So du over dx minus 2u minus over 3y equals negative 4/3 y. So this is now the simpler form. So now we'll get the integrating factor. We let v is equal to e to the negative 2/3 2/3y dy, and this is just equal to e to the negative 2/3 ln of y, right? Or just e ln of y to the negative 2/3, or y to the negative 2/3. So this is our integrating factor. Now, derivative of y to the negative 2/3 times x. So remember, our dependent variable here is x. Therefore, it's equal to our integrating factor, which is y to the negative 2/3 times
It's you, stupid.
negative 4/3 y, which is our g of x. So to simplify it, we have, okay, I'm gonna integrate this first. So y to the negative 2/3 times x is equal to, so 1 minus 2/3 is negative 4/3 y to the 1/3. And I'm not done here integrating, so should integrate this first. So y to the negative 2/3 times x is equal to negative 4/3. So 1/3 plus 1 equals times y to the 4/3 times 3/4 plus c. So we can cancel this one out. We have y to the negative 2/3 times x is equal to negative y to the 4/3 plus c, and dividing it by y to the negative 1/3, we'll have x of y is equal to, since we're gonna divide it, it will be plus, so 4 plus 2, we're gonna have negative y squared plus c y to the negative 2 of, this will become positive 2/3, and this will be,
Not that final
oh
answer.
wait, I just found out that there's something wrong with this problem. I must derive it. I'm using u because I let it when I'm using the Bernoulli equation, so this will be u, and u. So this is not yet the final answer. So returning the x variable, you know that u is equal to x squared, right? I remember this one. So that will give us x squared is equal to negative y squared plus c to the 2/3. And this is the final answer.
No.
Sorry. So do you agree that this will be the final answer? So honestly, I'm just kidding. So here's the final one. We missed the y here. It must have y, so y to the 2/3. So it's x squared plus y squared is equal to cy to the 2/3. And I'm sure, really sure, that this is now our final answer. Sorry again. So we have here our whole solution. Sorry for being messy, and you can pause it in the YouTube. So